Okay, so trigonometric identities, your purpose is to put one side in terms of the other side. I'm going to give you a process in order to solve them. Okay. The problem with people with trigonometric identities isn't the trigonometric identities, it's their algebraic skills. Right? Because really this is what this is testing, is you understand how to simplify algebraic expressions. So this is a list of the most common strategies used on performing substitutions as follows. So when you're solving trigonometric identities, the first thing you're going to do is choose a side. And usually what you want to do is choose a complex side. So you're going to move from the complex to the simple. So what you'll need to do is you'll need to find common denominators. You'll need to factor. You'll need to expand, whatever the question calls for. This strategy will always work. It's not necessarily the easiest one, but it'll always work for every single identity. Express all functions in terms of sine and cosine. Okay? So if it's not sine and cosine, change it into sine and cosine using your trigonometric identities. Once you've turned everything into sine and cosine, look for the Pythagorean identity. That's the one that you learned back in grade 11, and it's the one most common used. The sine of x squared plus the cosine of x squared is equal to 1. But also remember, you can rearrange that identity. So say you wanted to isolate sine x squared. That's equal to 1 minus cos x squared. And the cos x squared is equal to 1 minus the sine x squared. So a lot of times, you may need to substitute in for sine x squared, and remember that you can use the Pythagorean identity. So really, A, B, and C are the trigonometric processes that you would have used in grade 11. D now is grade 12 stuff, where if the angles aren't the same, make them the same. So that means using your double angle formulas. Okay, so express all functions with the same argument. That means anything that's a double angle, change it to a single angle using your double angle formulas. Okay? And the same with the addition formulas. And you'll have to answer that on the context of the question. Sometimes you can start with one of the sides and make it look exactly like the other side in the question. But if you can't do that, okay, then you start with one side, stop, and then start with the other side to make it look the same. Okay, so that's E, develop the two sides of the identity separately until one equals the other, or they both equal the same thing. Okay, so you don't have to make the left side look like the right side. You can start with the left side, stop somewhere, and then make the right side look like where you stopped with the left side. Okay. Any questions on that? So I've chosen 4 identities which different things arise. But again, it's like anything you do in life, the more you do of them, the better you get at it. Okay. So these identities, all of them can be solved. Okay. And they can all be solved if you use this process and use proper algebra skills. And that's the most important thing. And I'll talk about some of the most common mistakes people make at the end of the lesson to make sure that you don't make those mistakes. Okay, so just recall when you're solving trigonometric identities, you have to work independently with the sides. So you have to work independently with the left side and the right side. So starting with this question here, prove the following identity, that 1 plus the cosine of x is equal to the sine of x squared over 1 minus cosine. Okay, so this side here has 2 terms. This side here has 1 term, so I'm going to start with the more complex side, which is the one that has the 2 terms, which is the left side. I have 1 plus the cosine of x. Okay, so is there anything I can do with that, 1 plus the cosine of x? Okay, so maybe, this is what I'm going to say, so sometimes the more complex side isn't the best side to start with. Okay, so even though this term has 2 terms, there's nothing really I can do with it. If this term had a fraction, then at least I can find a common denominator. So really there's not much I'm going to do with it. So this side, even though the right side has 1 term, at least I can start to do something with it. Okay, because it's a little bit more complex. Again, If I look at both sides of the identity, and that's one thing you want to keep in mind too, is looking at them. The left side has cosine x in it. The right side has cosine x in it, and it has a sine x. What do you think I should do then? Yeah. Yeah, exactly. We use this identity to make everything all cosines, because that's the only thing that the left side has. So let's get rid of this sine x squared by using this. Okay, these are very common. This one here, the black, the red, and the blue, you're using these very common when you're doing them in trig identities. So I'm going to change the sine of x squared into 1 minus the cosine of x squared. Okay. So now what I want to do is I have everything in terms of cosine, right, which is good because the left side only has cosine in it, but I want to simplify. So in order to simplify, I'm looking now to maybe factor. How can I factor out the top? What type of factoring is the top, first of all? This is the kind of stuff where trig identities aren't hard. It's understanding grade 9 and grade 10 factoring. It's really reaching back to remember that. In fact, do you recognize what it is? It's exactly what it is, right? Difference of squares. Difference of squares is a perfect square, subtract another perfect square. 1 is a perfect square, cos x squared is a perfect square. So when you're when you're factoring a difference of squares, you reach back to when you first learned difference of squares, and it factors to 1 minus cos x times 1 plus cos x. Okay, and then what conveniently happens now when I simplify? Yep. Right, so 1 subtract cos x is a term, divided by 1 subtract cos x is 1, and I'm left with 1 plus the cosine of x, which is the left side, and I proved it. Okay, the next one, I'll show is a little bit more complex one. Okay, so but we're going to understand, again, the process. So somebody decide which side to start with and tell me which side we're going to start. Justin, pick a side. Plus. So in this case, they both look pretty complex, so it doesn't matter really which side you start with. And again, with any identity, it doesn't matter which side you start with. It's not like you can pick the wrong side. Okay? There's always something to do. Okay, so looking back at my rules, it says pick a side. We've done that. Express everything in terms of sine and cosine. This guy is in terms of sine and cosine. Use the Pythagorean identity. If you see it, there's not one there. Now we're on to this part. So I have to change everything that's a double angle into a single angle, right? So if I do that, I look at my formula sheet, and the sine of 2x is equal to 2 times the sine of x times the cosine of x. Then I'm going to use the double angle formula for cosine 2x. But the problem with that is there's 3 of them, right? So you have to choose one. When you do choose one, make sure, because you're replacing cosine of x, the cosine of 2x with what it's equal to, make sure you put it in brackets, because whatever negative has to be distributed inside of the bracket. There's 3 of them to choose from. All of them will work. One of them will always be easier. Okay? Which one do you think I should choose in this example? Does anybody have their formula sheets on them? If you do have one, take it out so that you can kind of know what I'm talking about when I do these. If you don't have one, then just follow along. And these are the type of tricks that that you, again, figure out as you go through them. Looking over here, right, there's no number 1. This has a number 1. I want to get rid of that number 1. So the one I would choose is the one that has one that I would be able to subtract off and get rid of that number 1. So which identity can I choose? Yep. Excellent. 1, negative 2, right? Sine squared x. again, the other two will work. Okay, it just makes it a little bit harder. But if you see now, if I distribute through, I get 1. Negative times 1 is -1. Negative times -2 is +2. So now what conveniently happens, and you should always look to choose, especially with the cosine identity, choose the one that's going to eliminate your 1, right? Because now 1 subtract 1 is 0, and I don't have to deal with those 1s anymore. And I end up with 2 sine x cos x over 2 times the sine of x squared. And now I'm ready to simplify, because I have one term on the top, one term on the bottom. Both of them are divisible by 2. There's a sine x on the top. There's 2 of them on the bottom, so I can take one of them out, leaving me with cosine of x over the sine, which looks nothing like the right side, but that's as far as I can go. Okay, so I can change it into cotangent, but I don't need to. Okay, so now my goal is to make this look like this, because there's nothing more I can do with that. You guys know what I mean by that? Okay, so I only have one option, and I'm going to write down what a lot of people do on a test, a common mistake, and then hopefully someone will tell me what it is. First of all, what's the reciprocal ratio for cosecant? Which one does that go with? Sandra? Right, okay. So the cosecant of 2x is the same thing as 1 over the sine of 2x, exact same thing. Okay? So I'm going to write that down. And I'm going to change the tangent into sine of a cosine. What did I do wrong? B?
The solution of going right beside the sine to x, it should have been right in front of the 1 over.
Exactly. Okay, that people do that. A very common mistake is they're like, okay, reciprocal, everything moves down. But remember, really what you're doing is you're writing the reciprocal of this. The 2 has nothing to do with this. Okay, so the 2 doesn't get moved. It's just going to stay up in the top. Very, very common mistake people make. So it would stay like that. Okay, what do you think my next step is to do now? Keeping in mind those rules. Yeah?
So you gotta change the double angle into single angle.
Perfect. Again, with sine, it's easy because you only have that one choice. Okay. How can I proceed from here? And remember, whenever you're solving an identity, right, and it's kind of a hint to the next thing to do, always look if you can simplify as you move along. Is there anything I can simplify here, Taylor? Right, so 2 divided by 2 is 1, 2 divided by 2 is 1. So now I'm left with 1 over sine x cos x minus sine x cos x. So I have a fraction, subtract another fraction. How do you subtract fractions? You, David, find a common denominator. What would the common denominator be in this case? God? Okay, so the common denominator would be sine x cos x, right? Perfect. So the common denominator is sine x cos x. This term here already had a sine x cos x underneath it, so I didn't need to multiply it. But like what Kyle said, I had to multiply this by sine x. It means I multiply the top by sine x. As soon as you see a 1 and one of those guys squared, you should automatically think Pythagorean identity. Okay? So what can I change 1 minus sine x squared into? Alex?
Oh no.
Okay. Good? Okay. And now you're pretty much done. Because you have one term on the top, one term on the bottom. Both the terms have a cosine in it, so you can simplify it into the cosine of x over the sine. So this is an example of, again, I chose this one because it had some double angle formulas in it. And I also chose this one because this is the one where you started with one of the sides and you can't make it look like the right side. So you have to do the right side and make them look the same. Any questions on that one? Okay. So the next one I chose is because it has the addition formula for sine. Okay, so pick a side to start with. Make it. Pick a side. That's great. Okay. So, make it pick the right side. The only thing I can do with it, right, is just like with the double angle formula. As soon as you see the addition one, use your addition formula for sine. So, I grab my formula sheet. The sine of x plus y is the sine of x times the cosine of y plus the cosine of x times the sine of y. And that whole thing is over sine x cosine. Again, remember, it's never wrong to pick a side, okay? Because at least you started. Okay, so I start with that. Anything I can do with the right side? Anything more I can do with that? Nick? No. Okay, so what do you think you should do now? Kyle? Mm-hmm. Which is totally fine, because you're going to see that this works out nice, that we expanded that. So on the left side, your first step is to change everything into sine and cosine, right? So 1 plus the cotangent of x, by definition, is the cosine of x over the sine of x. That's what the cotangent is. And the tangent of y is the sine of y over the cos of y. So I can multiply those two guys into making one term. Cos of x, sine of y, sine of x, cosine of y. I have a number added to a fraction. How do I add fractions again? Yeah, common denominator. My common denominator in this case is sine x cos y, which is convenient because this is what we want the bottom to be. And when I do that, I multiply the 1 on the bottom by sine x cos y. That means I multiply the top by it. And it looks exactly like the right side. Now you're done. So it's never wrong to pick a side, choose a side, and then do something with it. Again, this process right here, right? Choose a side, make sure everything is sine and cosine. You look for the Pythagorean identity if you need to. Okay, just don't randomly change things if it's not getting you further for solving identity. And then everything that's a double angle formula or the addition, use the formulas to expand it. And then again, make one side look like the other side, or work with both sides to make it look like the same thing. This example I chose right here because this example here, you can't do any of those common procedures to help you solve this identity. So you look at it. It doesn't matter which side you start with, the left or the right. It's always, there are all already in terms of sine and cosine. Okay? 1 minus sine x, and I get this for some reason, is sine x squared is equal to 1 minus cos x squared. So then it must make sense that sine x is equal to 1 minus cos x. Right? That seem fair? John? No. Okay, so that is mathematically not correct. So you just can't get rid of those squares. Okay? So I can't change that. There's nothing I can do there. Okay? There's no double angle formulas. There's no addition formulas. So there's really nothing I can do. So what you need to do is start with a side. Somebody pick their side. Do you have any family extension to its left or right side? Say one of these. Pardon? Right? So at least choose a side. Never leave anything blank on the identity test. Okay? If you've gone through that procedure and there's nothing left you could possibly do, the last thing you have to try is rationalizing. What do I mean by rationalizing? What do you do? Remember that we've done where we rationalized the denominator before and we multiplied by the conjugate? Does anybody remember what the conjugate is? Remember what it is? Okay. So you multiply by the conjugate. The conjugate's the exact same thing with a different sign in the middle. You do that to the bottom, you do that to the top. So when all your procedures, everything, there's nothing left you can do. Your last step is to multiply by the conjugate. So I'm going to multiply the top. I'm just going to put them beside each other and you'll see why in a second. Just save yourself a step. And you should do this whenever you multiply by the conjugate. So this times that. And on the bottom, the reason that you have the subtraction is so that middle terms would cancel out. 1 times 1 is 1. 1 times negative sine x is negative sine x. Negative sine x times 1 is positive sine x. They cancel out. And sine x times negative sine x is negative sine x. But if you do that, right, if you ever multiply by the conjugate, now you're going to end up with 1 minus something squared. And what can I change that into? Yep.
Cosine squared.
Correct. So you have one term on the top, one term on the bottom. They both have cosine. Cancel it out. And you've changed 1 minus sine x over cosine of x. And you change it to the left side. Okay? It's important to note, if Serene would have said start with the left side, then I would have had 1 minus sine over cosine. Then you would multiply by the conjugate, but you'd be multiplying on the numerator. And that's fine to do. Okay? You don't always rationalize the denominator in math. For anybody going on to university, there's many times you rationalize the numerator, especially when you get into calculus and evaluating limits. Okay. Any questions? Okay, so I'm going to go over a bunch of common mistakes I see all the time, and then because really, like I said, this really isn't testing whether you understand trigonometric identities. Okay? That's just a vehicle to really test your algebra skills. So if I get this on a test, people will write this. Good, bad, can't do it. Why can't I?
Well, you usually get your 1 from
Well, I did get my 1 from anywhere because sine x, I'm divided by sine x, right? So sine x divided by sine x here is 1, right? Okay. So is it legit, maybe?
That's too easy
It is too good to be true, right? Sure?
Yep, divide every term by sine x, and then divide both by cosine.
Exactly. Okay, when you're simplifying algebraic terms, all the terms have to have your common factory dividing factor. Okay? And again, terms are separated by addition and subtraction signs. So again, that doesn't work. Then I'll get something like this, sine x plus cos x sine x over sine x. And then people are like, oh, okay, good. Everything has a sine x in it. So I'm going to cancel this out, cancel this out, cancel this out. My answer is cosine. That happens all the time. What did I do wrong there? Yep. Exactly. Okay. So make sure that you put in account for the 1. So you're not getting rid of that. You're just dividing this term by sine x. You should be writing the answer back. Make sense? Okay. So those are common mistakes. Also common strategies. If you have the tangent of x, okay, so the tangent of x squared, remember that means the exact same thing as you can change the tangent to sine over cosine, and all of that is squared. So you can change the tangent of x squared into the sine of x squared over the cosine of x. All right, make sense? Okay. If you see the tangent of 2x in an identity, what do you think you should change it to? Yep.
Use the double angle formula.
Right. Okay? That's what 99% of the people are going to do. I don't want you to use the double angle formula for the tangent. What do you think I want you to do? Yep.
Like sine 2x over cosine.
Exactly. Okay, so change it into, in terms of sine and cosine, then use your double angle formulas. Okay? The only time you would ever use your tangent double angle formula is if the whole entire identity only had tangents in it. Okay? Then you can just work with tangents. Okay? If not, remember, your first step is to change everything in terms of sine and cosine, so then do that. So then these are some common strategies for tangent. And again, cotangent, right? Don't change cotangent into 1 over tan. Unless everything, the whole identity had tans in it, and then that makes sense. Change it into cosine over sine. Which I don't think is on the identity sheet, but you can add it to it if you really think you're going to forget it. Okay, so some common algebraic mistakes. And then I try to choose 4 examples that a whole bunch of different situations come up. Every trig identity is different. The more you do, the better you get at them. So that is the only